Okay, since we derived this, I thought it'd be useful to just do one example where we apply these equations. So we'll go back to our mercury example. The liquid mercury has a heat capacity of 27.98 joules per mole Kelvin. The gas is a monoatomic, essentially ideal gas, so its Cp is 5/2 R, which is 20.79 joules per mole Kelvin. And I can now use these equations to see what delta RH naught and delta RS naught is at 400 Kelvin. So again, the steps here, first we're going to do delta RCP is equal to gas minus liquid, so 20.79 minus 27.98. This is negative 7.19 joules per mole Kelvin. And again, we're assuming here that this is basically constant with temperature. The liquid's heat capacity varies a small amount with temperature. The gas's heat capacity is almost essentially constant. Again, this is a very small difference, so that's why delta H and delta S are not going to depend much on temperature, so we'll see that in a second here. Now I can plug that in. Delta RH naught at 400 Kelvin is going to be equal to delta RH naught at 298, which we had from the table, plus my integral here, since Cp is constant, or delta RCP is constant, this integral will go away. Since it's just a constant number here, times dt, the constant comes out of the integral, and we're just going to get this times delta t. Admittedly a bit ugly with all those deltas, but this is going to then be delta RCP times delta t. And so my final answer here is this term here. My delta t is 400 minus 298.15. My CP was this negative 0.719. This is negative 733 joules per mole Kelvin, which again I have to make my units match, which is negative 0.73 kilojoules per mole Kelvin. And again, I've done all this work to arrive at delta RH naught of 400 Kelvin is equal to 60.7 kilojoules per mole Kelvin. So again, a very small difference here, which is why we're normally okay assuming that this doesn't depend on temperature much. Again, there's exceptions, but it's normally a quite good assumption. Okay, this next integral works the exact same way. Again, normally I should do an integral here, but if delta RCP is constant, it comes out of the integral. dt over t integrates to ln tf over ti. And so I can say that this is delta RCP ln tf over ti. And then again, now here my units do actually work out properly here. So that's good. Times ln of 400 over 298.15. And I get here my change to delta S is, again, multiplying this thing out, negative 2.1 joules per mole Kelvin. And I get my delta RS naught of 400 Kelvin is equal to 97.0 joules per mole Kelvin. Not too bad. Again, we can see a good assumption. We've only changed by a couple percent our delta H and delta S.